Hey, what's up, YouTube fans? So, what I wanted to talk about in this video, right, is the evolutionary reducibility of the human brain and of its connection to the rest of the body, right? So, something which certainly can have the appearance of being irreducibly complex is how the rest of the human body relies on the brain, right, in order to work. And without the brain, we can't move around. Our heart will stop beating. The rest of our body won't work without the brain. And so some will think that that proves that it had to have always existed in our ancestors from the beginning, right? Like there was this guy on the internet before who said to me, please explain to me how our ancestors survived for billions of years with no brain or heart or lungs or reproductive organs. But so this is the thing. It actually is very easy to demonstrate the reducibility of the human brain, because so not all living things have brains, obviously, right? And even amongst creatures with nervous systems, not all of them have brains, right? So even though the brain is the most important part of the nervous system in humans and in most animals, there are many animals which have a nervous system but no brain. Um, comb jellies and jellyfish, which are a few of the most primitive living animals, right? They have a nervous system, right? But no brain, right? Also, some other animals like starfish, right? Although phylogeny would indicate to us, based on which other creatures are most closely related to starfish, it would indicate that they likely evolved from creatures which did have brains before but went on to lose their brains. But in the case of comb jellies and jellyfish, they're a few of the most primitive creatures to have nervous systems, and their nervous system works with no brain. So their nervous system setup is called a nerve net. And even though there's no brain, there's still nerves, muscles. They can still move around and be very active, right? And there's even studies that have indicated that jellyfish have a certain degree of memory, right, based on the way they react to their environment, based on past experiences, right? Um, and yet they have no brain, right? And so, while for the human body, it obviously won't work without a brain, right? Um, for many living things, their body will work without a brain, and even for many things with the nervous system, it still works without a brain, right? And the evolution of the brain happened hundreds of millions of years ago, long before we were human, and so long before our ancestors were, that is. So, it really doesn't matter if humans can't survive without a brain, right? Because our ancestors were not human back when they didn't have brains, and they were very different from humans. And this is what's more, so even amongst creatures with brains, many of them, their nervous system can still be very active even when disconnected from the brain, right? So even though for mammals, including humans, the body will not tend to be able to move around at all once the head is removed. In plenty of other animals which do have brains, even though they do have a brain, their nervous system is not as much dependent on the brain as it is for us. And so when their head comes off, they will still be able to move around, right? So there's there's a lot of good YouTube videos on this. And now I'm not saying that the YouTube videos in of itself prove that it's a thing. There's also scientific literature that you can read on these things. But if you want to see videos of it, it's actually pretty hilarious. There's like videos on YouTube of like snakes that have been beheaded, right? And both their head and the rest of their body continue to move, so their jaw is still like moving, and their rest of their body is still slithering, and the motions of how the rest of their body is slithering is pretty much identical to how it looks when a regular living snake moves, which just comes to show how little consciousness is involved with their movements. That would seem to indicate, right? But what's funny is in this one YouTube video, the snake, it's actually its own head bit the rest of its body, so it was a headless snake, and the rest of its body that was slithered in front of it, and it triggered its instincts that would like attack like prey, you know, and so it bit itself. I might even share some of those videos on my YouTube channel if YouTube will allow for me to copy the video. I don't know if it'll allow it or not. And then also for frogs, they can move when their head comes off, and even when they're skinned and when most of the guts of their body are dumped out, you can find videos of them still hopping even, and the motions of how they hop is really, it looks indistinguishable from the way it looks when a living frog hops. It doesn't even like hop differently, like it's literally the same motions, right? It hops identically, at least it, you know, I'm not like someone trained to study the way that birds hop, but from my experience watching birds, or I mean, frogs hop that are alive versus, like in these videos where they're like headless, the way they hop is identical. I see no difference, right? No noticeable difference. It's the same pattern of how they move, right? And even like when their legs are disconnected from the rest of the body and all it is leg, in the case of frogs, it's actually a known thing that when, as at least like it has to have been killed recently, right? But so if you sprinkle salt on the legs will actually like twitch, and they'll like retract, they'll start moving, and they'll even wiggle the toes. And it looks very similar to what we would see in the movement of the toes on a living animal. And I mean, shit, it even looks like what I see on my own body when I reflexively move. Like if I'm just like sitting there and like a mosquito were to bit my foot, the reflexive movement that I would see from my own foot is pretty much the same basic motion that I observe when I see these frog legs that are disconnected from the body moving, right? Which just comes to show how little consciousness there is with some of the movements, and how the nervous system can be very active without the brain's intervention. Also, you know, birds like chickens, for example, when their head comes cut off, they will oftentimes run and even flap their wings. And sometimes they'll flap their wings that it even makes them go up into the air slightly. Like, I don't know about, not necessarily like up into the sky, but it'll at least like make them like up off of the ground, like a little bit, like just like briefly rise above the ground with their head off. And for octopus, even though they have brains, when their head comes off, their arms will still move around. You can find YouTube videos of that. For insects, most insects can still move when their head comes off, even though they have brains. But when the brain is disconnected, the rest of their body can still move for a period. And you could even find YouTube videos where the head comes off and then the insect picks up its own head and flies away with it, which is pretty funny. And And also in the case of there's some flatworms, right, which can regrow any part of their body, including their brain. So there's some flatworms which literally have brains, but they can regrow any part of the body, including the brain. And so, like, if let's say if the part of their body with their brain becomes disconnected, they can regrow a new brain and it'll still work. And so even when the brain was first evolved, the rest of the nervous system could still have the capacity to be highly active without need for the brain to always be intervening with everything. And it could only be much later that the brain is how it like that you have this setup that we have in mammals such as humans, where most of the rest of our body won't move around once the head becomes disconnected. You know, and so, you know, it could still be advantageous to evolve a brain even when the rest of the nervous system still has the capacity to be highly active without the brain. There could still be evolutionary advantage to evolving the brain. And then, okay, so this what's more. So the brain itself, the structure of it in a human is not irreducibly complex, not by a long shot, because you obviously don't need the level of complexity found in humans or anywhere near it in order to have a fully functional brain that can still have evolutionary advantage. So, I mean, we even know this from humans because there are some instances where a person will have to have a procedure in rare instances where like a significant portion of their brain is removed, right? And but oftentimes those people can still stay alive, or at least I think it's pretty rare, but you know, it can happen where they're still alive and walking around. Like you can't remove the whole brain, mind you, but you can remove some of it, at least a large portion of it. And in our closest living relatives, the chimpanzees and bonobos, the organ of the body which is most different between us and them is obviously the brain, right? And our brain is actually about 3 times the size of that of a chimpanzee. But they obviously still, their brain still functions just fine, at least for, you know, the things that they need in order to survive and reproduce. And I mean, there's obvious differences because of their difference of brain. You know, that's why, you know, the fact that we have much larger brains, that's why we don't go around being like ooh, ooh, ah, ah, and all of that. But you know, their brain obviously still functions enough for them to be able to survive and reproduce and to get evolutionary advantage from it. It's useful in its own right, even though it's much smaller than the human brain. And there's also unique the placental brain, right, which includes everything from bats to elephants to horses to humans, and all primates. You know, it's a big group of mammals. Placentals are distinguished from other mammals and from other animals for that matter in a number of ways. One of the ways is there's a unique region of the brain found in placentals, including humans, called the corpus callosum, right? So that is why you have a corpus callosum in your brain. It doesn't have to be there in order for the brain to work at all, which is proven by other animals that are not placentals. And you know, placentals also have other features in common, like belly buttons. But that's off topic from what I'm talking about here. So then also all mammals, so also marsupials and monotremes and placentals, all mammals, including humans, everything from platypus to elephant to kangaroo to bat to chimpanzee to human, all mammals have a neocortex, right? We have a region of our brain called the neocortex, and this is found in all mammals and only mammals, right? And so, other animals, like for example, reptiles, they don't have a neocortex, but they still have brains which still work just fine without the neocortex. And then is because we are vertebrates that our brain is divided into the front brain, midbrain, and hindbrain, and each of those regions of the brain has unique regions for vertebrates also that are not seen in invertebrates. Um, and so the vertebrate brain is unique, distinct from the brains that we find in invertebrates, right? But the invertebrate brains still work, right? Even though they are different in these respects, they still have fully functional brains. So the brain, it did not have to be anywhere near its current level of complexity or structure in order to be useful at all, right? It can be divided in, or I mean, it can be broken down into a series of evolutionary steps leading up to the current brain. It doesn't have to all come about at once in a single step. And there's also fossil evidence for the evolution of the brain over time, showing that when we look back at earlier hominin species, we see a trend specifically in the Homo group of the brain size getting larger over time, right? So, the further back in the fossil record, the smaller the average brain size is for hominins. And then you go a certain point back and you only find things, amongst hominins, you only find creatures with a brain size within the range of that of chimpanzees. Um, it's only later in the fossil record that you get things with brain size bigger than that, and eventually the size that we have. We actually don't have the largest brains relative to our body size of all living primates, though, only because the Neanderthals actually had a larger average brain size relative to their body size than we do. But aside from them, all of the rest of the Homo species had smaller average brain size than us, if I'm not mistaken. At least the earliest Homos did. And so, yeah, that's all for now. See you guys.